Hello everybody, my name is Rohaizan Omar. I'm a master student in Mechanical Engineering, Faculty of Engineering, Universiti Malaysia, Sabah. I'm under the supervision of Dr. Muhammad Kamal Muhammad Shah. Today I would like to present regarding the study on smart microgrid system, the preliminary work that have been done by us. First, I would like to introduce what is a microgrid. The definition of a microgrid is a self-sufficient small-scale power grid that can operate independently or collaboratively with small power grid or even the main power grid. And there are few characteristics of a microgrid. The local energy production and also a transmission system, which can work independent or dependent. And one of the main character is it has to be intelligent. We have identified the problem statement. Number one is the increase in demand, meaning at this present moment 1235 megawatt is being supplied to the grid, which they are having a 29% of reserve margin, 3% increase between 2030 to 2037 have been predicted, and 224 megawatt have been exported to East Coast. And the reliability of our present transmission system is very poor, with the operating reserve is less than 100 megawatt or 70 days, and gap in transmission from west to east. And for the high dependency, 78% the generation is by gas, 12% by diesel, 7% hydroelectric, 2% biomass and biogas, and less than 1% from solar. The energy distribution, it is very unbalanced from west to east energy transmission, especially on the Kolopis to Segaluit 275 kilovolt transmission line, and low generation of capacity is very inefficient and costly for the diesel generators, and it is also is very high cost. 840 million have been allocated for the upgrading and installation of new transmission line, and 2.3 billion ringgit to strengthen the existing transmission and distribution system. This is our targeted objective. Number one is to identify the potential renewable energy resources in Sabah for reduction of carbon emission and the lower cost of production. And number two is to determine the load characteristics at the smart microgrid by conducting an analysis of data. Literature review. We have made a compilation and a study of available literature. For the renewable sources, commonly available commercial source is from number one is the solar energy. Solar energy meaning the solar panel, which change the sunlight into electricity in DC form by transfers of electron, and it depends on the geographical and the climate factors. The advantage is the flexibility of the sizing. And the wind energy is harvested using a wind turbine. And this depends on the wind speed based on region and also this month. But it required a minimum from 3 meter per second to 5 meter per second of wind velocities for the wind turbine to operate. The third one is the hydroelectric. It will be harvested by generators that are run by the turbine that convert the potential energy of flowing water into their mechanical energy. And there is also a small scale hydropower, or call it micro hydroelectric. So these are the three sources that is commonly being used right now. For the load demand, at this moment in Malaysia there are three power provider. Number one is the Tenaga Nasional Berhad. Number two is Sabah Electricity Sdn Berhad, or SESB, and number three is Sarawak Electricity Supply Corporation. And it has been projected to increase at 4.7% annually and reach 274 terawatt hours in 2030, with 5.4% from industrial sector and 4.9% from residential sector. And by 2030 also, the electricity demand per capita is projected to become 7,571 kilowatt hours per person. And in order to cope for this demand and flexibility, Microgrid is the way of doing. It may assist in meeting the rising of the load demand. One of the main component for the microgrid is a power converter. The power converter will convert the electric power from one form to another between AC and DC, alternating current and direct current, and changes the magnitude and phase of voltage or current or frequency, or the combination of these factors. Inverter is the device that converts DC current to AC current. For example, it converts the DC power from sources like battery to AC power for many home applications. In other words, it converts the electricity generated in household, like from a solar panel, and supply electricity into the grid, electric grid, which is using the AC, or the alternating current. One of the important component in a microgrid is the energy storage. Energy storage is a backup or the energy buffer to combat the imbalance in supply and demand of electricity. For example, like we have our solar panel, which depend on the sun itself, will make it very unstable during the availability of sun and the non-availability. So we need the intermediary or the energy storage to store the power and to be used later on. And number two is storing or saving energy produced now and use it for future usage and demand. You will store whatever we are having now and we can use it later on. And the fluctuation and intermittence from unstable sources and non-linear load of a power system. That is one of the other function that energy storage can do. There are two types of energy storage. One is the distributed energy storage system, and the other one is the centralized energy storage system. Okay, I would like to highlight the Sabah electrification industry. Right now, the maximum demand for the Sabah overall is 955 megawatt, which West Coast consume 651 megawatt, and the East Coast is 311 megawatt. West Coast is in the Kota Kinabalu side, and the East Coast is on the Tawau side. And the distribution of the electricity is by using the East Coast grid through 275 kilovolt of Kolopis Sigaluit line, which transfer 224 megawatt of electricity from west to east. And the demand percentage for the commercial market is 44%, domestic market is 34%, industry market 21%, and others is 1%. The dependable capacity is 1,235 megawatt, and the mixed power generation is 6,512 gigawatt hours. And at this moment, the renewable energy capacity is quite low, which the generation is produced only 134.2 megawatt. And this is the capacity percentage and the generation mix of Sabah electrification industry, where the main generator is using the gas powered, which is 78%, and diesel is 12%, hydroelectric 7%, biomass and biogas is 2%, and solar is being very low utilization of less than 1%. It same goes to generation mix, which gas dominates the main, which consists of 86%, hydroelectricity 7%, diesel 4%, biomass and biogas another 2%, and solar is using less than 1%. And Malaysia have set a standard, our national goal, to have the 20% of generation mix through renewable energy by 2025. And the main target, 59% is from solar, and 29% from biomass, 7% biogas, and 5% mini hydro. That is our national direction of this renewable energy. Methodology. Okay, we have set up a method of how to proceed with this study from start until the end. There is a technical analysis scope, and by having all those analysis, we can come out with our financial analysis. And based on that, we'll make the decision either it is a minimal amount of LCOE and NPC or not. If not, then we will repeat the process until the optimal solution is determined. Okay, I will explain detail on this. So for the methodology, on the first is the site selection. We have choose Faculty of Medicine and Health Science in the main campus of Universiti Malaysia Sabah, Kota Kinabalu. This is the latitude and longitude of the location, and the tariff is commercial tariff, which is for medium voltage and general commercial tariff. So we are simulating it using a software, and we will coordinate we will key in the coordinates, the time zone, solar irradiation, the clearness index, and also the monthly average air temperature. For the analysis of load demand, there is a synthetic load to be created, and then the selection of a load profile, yearly load fluctuation, scale annual average, and also hourly and daily data. System layout, we have chosen the PV panel from sun power and the converters for the 1 kilowatt of the generic lead acid batteries, and grid plus the input of the caustic. For the algorithm, we key in the annual electricity production, the maximum amount of power that can be charged and discharged, the calculated every 1 hour timeline. And on the optimization, the simulation will be run and compare the load demand with energy production for each step time, and then calculate the energy flow to and from every component. And lastly is on the financial analysis. By having all those data, we will calculate the levelized cost of energy, or LCOE, the net present cost, which is an NPC, and compare to the best optimal microgrid system. This is our system layout, which is tariff CM2, primary load of 10,000 kilowatt hours per day with 1,500 kilowatt peak, converter, and PV module and the battery connected in DC bus and convert by the inverter to the AC bus. And we have come up with the result of our simulation. So this is the resource analysis that we have identified. This is the monthly average solar global horizontal irradiance and the clearness index. See, from January until December, and the most high in the daily radiation is on March and April. And this is the average daily temperature in Celsius, and the maximum temperature is achieved in May, and the highest is from April, May, and June, which is more than 26%. And this is the annual average of 5.4 kilowatt hours per meter squared of solar radiation per day, which the average clearness index per month is 0.5, and the annual average daily temperature is 25.68 degrees Celsius. And the load analysis based on the commercial consumption, as you can see in the graph, this is the kilowatt usage, and this is the time or hour of day. And for the commercial, from 8 o'clock until 4 o'clock is the constant peak usage, and it reduces when it becomes evening, and there is very low consumption during night time. And the baseline data is 2000 kilowatt hours per day, and scale annual average is 10,000 kilowatt hours per day. And this is the daily average profile of the load data. And this is the graph for the load data monthly profile, and this is the average electricity consumption, which we conclude that the daily is 18,730 kilowatt hours per day, which monthly of 59.7 megawatts per month, and annually 6,836.6 megawatt hours. And the highest demand that we have captured is in on the 19th August, where the highest demand is 1,517 kilowatt. So that are all the load demand that have been captured during our analysis. So as the conclusion, the result show that there is a high potential of generating power using solar in Sabah, and the data analysis can be done using a simulation software such as Homer, and the load characteristics and demand was successfully determined and analyzed. So that is my presentation for today. Thank you very much for your time, and thank you.